Hi students, in our previous video we had discussed about extraction of metals of least in reactive series, and also we had discussed about extraction of metals of middle in reactive series. In this video we are going to discuss about how to extract the metals of high in reactive series. So let's go to the point here. We know the highly reactive metals, they are not found in their native state. They are present in their combined state due to their high reactivity. Let us take some examples of metals of high in the reactive series. We know potassium, sodium, calcium, magnesium. These are all present in high in reactive series. So they are not present in free state, means they are present in a combined state, like the chlorides. One example I have taken. Let us take one example. If you take the sodium, sodium will be present in the combined state as the sodium chloride. Now our task is how to extract this sodium from sodium chloride. In this case, the metal chlorides, they are allowed for electrolysis of their molten metal salt solution. Here they are extracted by electrolysis of the molten metal chlorides. What is meant by molten metal chloride? Last time we had discussed in the ionic compounds about the electrical properties. Ionic compounds in their solid state, they do not conduct electricity, but in their molten state they do conduct electricity. What is meant by molten state? If you heat a solid sodium chloride at a very high temperature around 1074 Kelvin, then that will be converting into sodium chloride liquid. There is no water there, it is sodium chloride liquid. So the liquid form, it is called as the molten state. Liquid form of the solid is called as the molten state. Such kind of molten metal chloride on electrolysis. There is no diagram representation here, just equations only will follow here. On electrolysis there are two major points that take place here. At anode, remember children, at anode oxidation takes place. What takes place at anode? Oxidation takes place. What is meant by oxidation? Loss of electron. Now when we study this sodium chloride in the molten state, we know it is present in the Na plus and Cl minus, because the supplied heat energy overcomes the forces of attraction, so they are apart from each other in the ionic form. Which is negative form there? Sodium or chloride? Chloride is the negative form. What we are speaking at anode, oxidation takes place, and we are saying loss of electron takes place. Already sodium has lost one electron and now it is in a state of 2, 8. But chlorine is in a state of 2, 8, 8. That is the electron configuration, right? Now loss of electron. Sodium already achieved the nucleus configuration. Chloride also achieved the nucleus configuration. But here the chloride ion, that will lose one electron. It will lose one electron, and that will be converting into Cl2 gas. We cannot write Cl alone, so we represent as the half Cl2 gas. electron, what takes place? Reduction takes place. Reduction means gain of electron. Who is going to gain the electron means our sodium. That lost the electron, it is going to gain the electron and that is going to convert into solid sodium. So by this we are going to extract sodium metal from its molten metal chloride. So this process of extracting highly reactive metals from their molten salts are possible with the electrolysis. Simple words are: at anode, oxidation takes place, means chlorine is losing the electron to form the chlorine gas. So at anode, what is collected? Chlorine gas is collected. And at cathode, what is collected? The sodium metal is collected. So this is a simple method. So let's go on with the topic like after extracting any metal, it is not in a pure form. It will be having some impurities in it. Now our task is to remove those impurities. Such kind of process we call as the electrolytic refining. What do we call as the electrolytic refining? And for what metals do we apply this one? Like we apply for zinc, copper, tin, lead, silver. These metals are refined. Means from the metal which is extracted with some impurities, it is further refined. Impurities are going to be removed from it by the electrolytic refining. Very important for the objective also. So let us go into the topic by first getting the diagram of the board. Then I will give the explanation. So let us see the last refining children here. After extracting the ore, means after extracting the metal from the ore, this metal will have some impurities. And now our task is to remove the impurities from the metal. This will be done by passing the electrical energy towards to the impure metal rod, making it as anode. See here we are having one very important diagram for this topic. This topic is called electrolytic refining. What is the purpose of this electrolytic refining? It is used to remove the impurities from the metal extracted from the ore by passing electrical current towards to the metal. This metal I am using as copper. By the electrolytic refining method, we can refine the impure metals like copper, zinc, tin, nickel, or even silver. We can refine these impure metals, means we can get them into the pure state. So the important diagram is what things we want. We want a battery for the source of electrical energy. This battery will have positive terminal and negative terminal. Positive terminal is connected to an electrode. This electrode is of the impure metal rod. In this case, I am going to explain about the electrolytic refining of copper, impure copper. So, at anode, how can we say anode? In the case of electrolytic cells, the positive terminal is connected towards the battery. So here we call this one as the anode. In the anode, we are taking the impure copper rod. It will be little thick. It will be little thick or broadened. And the negative terminal of the battery is connected to the help of a key. Once the key is turned on, the negative terminal will be connected towards to the cathode. This cathode is a pure copper rod. It is a pure copper rod. And it is how is the way? Thick or thin? It is thin. But the anode is thick. Why and what will happen at the last I will explain very clearly. These both are dipped in a solution, salt solution, that is prepared from the metal solution. What are the electrodes we had used? We had used copper. So our salt solution must be the metal sulfate. Like it is copper, so I had used copper sulfate. It is so we call electrolytic solution. Electrolytic means this compound will dissociate into ions in water. How is it going to dissociate into ions? Cu2 plus ions and SO4 2 minus ions. Aqueous means they are combined with water. See here, what are the ions present? Cu2 plus ions are present and also SO4 2 minus ions are also present. Where are they present? They are present in the water that are derived from the electrolyte. Now once we turn on our circuit, at anode, the impure copper from the copper rod, it will undergo oxidation. We have already learned at anode what will happen, children? At anode, oxidation will happen. Oxidation means loss of electron. Yes or no? Loss of electron. Now here from this anode, the copper will enter into the solution in the form of Cu plus 2 ions. See the copper that is present at anode, that is undergoing the loss of electrons. 2 plus electrons it is losing, it is entering into the solution by losing the 2 electrons. Now this Cu2 plus ions that were entered into the solution, they are present there. But what is the cathode work here? At cathode, here the cathode, the reduction takes place. What takes place? The reduction takes place. What is meant by reduction? Gain of electrons. These gain of electrons means the number of Cu2 plus ions that are entering into the solution from the anode will be equal to the number of Cu2 plus ions that are getting deposited at the cathode. Because at the cathode, what charge is present? Negative charge is present. Negative charge means that is due to the presence of electrons. So on cathode, what are present? Electrons are present. What we are saying at cathode? Reduction takes place. Reduction is gain of electrons. These electrons will be given to this copper. Means this copper will be attracted towards these electrons. Those electrons will be flowing to the solution, they will be reaching here. And the copper ions will be deposited on the cathode. So Cu2 plus ions from the aqueous solution, they will be gaining electrons from the cathode and they will be deposited at the cathode. I am repeating the point again. At anode, the impure copper metal will undergo oxidation. Means the copper from there that will lost 2 electrons in solution and that will jump into the Cu2 plus ions. The number of Cu2 plus ions leaving there, these copper sulfate solution which is already having Cu2 plus ions, they will be attracted towards the electrons at the cathode. Cathode means negative charge. At cathode what will happen? Reduction takes place. That is gain of electron takes place. Means these are going to gain the electrons and they are going to deposit. This will take place for a long time. Means completely at the end of the experiment, what will happen means this anode will become thin. Because all the copper metal is going to be entered into the salt solution. And from the salt solution, the number of ions that are entering here are depositing on the cathode. Means at the end of the experiment, the anode becomes thin and cathode becomes thick. What is anode? Impure copper metal. What is the cathode? Pure copper metal. Now what is our task? To get the pure copper metal. Means now we got a pure copper metal. And where are the impurities? Here copper ions are moving, but where are the impurities? See, the impurities will be settled at the bottom of the anode. This is not now electrolyte. The impurities will be settled at the bottom of the anode. These impurities that settle at the bottom of the anode, that is called as the anode mud. That is called as the anode mud. Okay, children. By this method, we can refine the metals like copper, zinc, tin, lead, and nickel and silver. Once again, we are going to just recall some points here. The metals extracted from their ores have some impurities in them. Electrolytic refining is the process in which the impurities from the impure metal are removed by passing electrical current. An impure metal rod is made as anode. Very important point. An impure metal rod is made as the anode. It is thick in the starting. And pure metal rod is made as the cathode, which is thin. These are dipped in their salt solution. This is at the starting stages. The impurities are settled at the bottom of the anode known as the anode mud. This is most asked as a 1 mark question. By this, we need to write the anodic reactions and cathodic reactions, and the diagrammatic representation is very important. By this, we have completed the topic extraction of metal and also refining of the metals. In the next class, we shall see how to prevent the metals from the corrosion. Thank you, children.